now we have another excellent speaker, Mounia Ziat, who's a professor at Bentley University. I noticed some people from Bentley in the audience. Mounia studies haptic perception in order to understand all aspects of human touch. And tonight she's going to be talking about understanding how haptic technologies can be used to improve the virtual reality experience. So I'm going to turn it over, hopefully, to Mounia. I'll stop sharing now and she can share her slides.
Can you see my slides?
Yes.
Thank you. I just need to close the window on the side. Thank you so much, Wendy, for the introduction and for having me today. I'm very pleased to be here with you, and I've already checked some questions in Miro that I hope we can discuss after the talk. This is an overview of what I'm hoping to discuss today, and I will try to stay on track, and I have a few studies to go over. My PhD work was related to sensory substitution, a field that has been pioneered by Paul Bach-y-Rita, who is also considered the father of neuroplasticity. The principle of sensory substitution is using a sensory input such as touch to replace or substitute a missing sensory input such as vision. In this image, you can see the TVSS, which stands for Tactile Vision Substitution System, which captured an image and converted into tactile simulation. The concept was cutting edge back in 1972, and it still is because it's opened a lot of interesting questions related to human perception. This system was supposed to restore the sense of vision in blind people. The reason I'm mentioning this work because it's related to the concept of qualia. The TVSS was a technological success, but it was a commercial failure. And one possible reason is for this is the lack of emotional quality of the perceived object, which Paul Bach-y-Rita refer to as qualia in a paper I put in the reference for you. Despite the high quality of recognition, blind people using the system did not feel any emotion. And the paper discussed multiple stories, and there was one story about blind people that were able to recognize their wives and family members, but they did not express any feeling or emotion. This is a system I use for my PhD work named Tactus, which is a minimalist version of the TVSS or the concept behind the TVSS. This matrix that you can see of 16 little squares that you see moving on the screen was the equivalent of the camera. It recorded any contact with the virtual shape and converts the virtual shape into tactile simulation. I use a lot the minimalist approach in my research because it has the advantage of testing and understanding human perception without using highly expensive equipment. People can identify and recognize shapes and letters in very, very short period of time, between 3 to 5 seconds. So the problem, it's not a difficulty problem, but the question remains why these systems are not widely used, especially with the development of virtual reality. So I have been thinking about this question of qualia quite a lot. As a haptic researcher, the goal of the body of work I'm presenting today is to understand how a tactile supplementation is perceived emotionally by the user, understand how tactile inputs affect vision and in turn are affected by visual stimulation, and provide design principle and guidelines for engineers and designers to help them integrate this technology in a way that is accepted by the user and becomes fully part of the multimodal experience. We can all agree that emotion play an important role in our interaction with the world. They can affect several decisions we make, and that usually lead to drastic changes affecting our lives. Stanley Weinberg published his novel Pygmalion Spectacle in 1935. And the replication of our world into virtual environment has been in human mind since. On one hand, we have never been closer to Weinberg vision because of the technological progress related to head-mounted display, On the other hand, we are still far away from his vision. For those who are interested to read the story, it's a very short novel of an immersive world that not only include all our 5 senses, but also provide us with some emotional quality. And one obstacle that users face to reach some sort of emotional qualia is the lack of tangible interaction or lack of physicality. For this reason, there is a growing need in creating new haptic technologies to enhance the user immersion. However, I think it's not enough to focus only on the quality of the device, the mechanical stimulation. It's also important to understand how the haptic sensation could trigger emotion during the interaction. So when someone is interacting within a virtual world, we can allow similar affective demonstrations such as fear, even stress, happiness. However, because it's not real world, the intensity of this emotion needs to be monitored and controlled, because of a drastic emotional change during the interaction could lead to an emotional distress of the user. I don't know if you're familiar with the show Black Mirror. Episode 2 of season 3 is an extreme case of what I'm talking about. The main protagonist got stuck in a VR environment, similar to what we see today, VR escape rooms, and he died due to extreme fear within this world. In terms of touch, there is physiological evidence that human hairy skin contain nerve fibers and has been linked to emotions. Those are known as CT afferent fibers, and they are connected to 3 types of hair. For instance, a gentle poke, like you see in this picture on the left, would mostly activate fiber connected to long hair. A firm stroke, such as rubbing, activates all hair types, and a gentle breeze will likely activate medium hair nerve fibers. My first investigation was to see how tactile stimulation and emotional images differ from a physiological point of view. My question was very simple. Would Eeg signal would be different or the same if touch is associated with angry, sad, or happy faces? And those are my collaborators for this work from CNRS Paris. We use the forearm as a site of stimulation to activate the CT afferent fibers. And we use an air jet stimulation. So the air jet nozzle, as you can see by this video, was controlled by a servo motor. And we project a different intensity of airflow. So I'm trying to. We had 3 air jet flow intensity, a tactile stimulus of a high intensity level. So we changed both the flow rate and the velocity. And we had a medium intensity and a low intensity level. We had 4 visual conditions, consisted of neutral images, and we use houses. And for emotion, we had happy faces, angry faces, and sad faces. So there was a mix of visual only condition and tactile visual conditions. Participants start staring at the cross and get exposed to a stimulus, and either visual only or combined, and answer on a 5-point Likert scale how the air jet feel on their forearm. We run 320 trials with all condition combined with the 19 participants. We recorded the brainwave using an EEG net from EGI of 64 electrodes, and you can see here the image of the participant in front of the screen and with the net on their head. We only look at 14 electrodes that are located, as you can see here, by this top right. I don't know if you see my mouse, but here it is, the one on the top right corner, around the parietal and the frontal cortices, where the somato and somatosensory area are located. And I'm only showing you the result for 1 electrode, which is shown by this little dot here. If you're not familiar with Eeg signals, so we do some kind of pre-processing, and once we process the data, we end up having a signal with positive and negative peaks like you see here, and we call those ERP components. For this experiment, we are looking for N100, which is a negative peak at that appear at the pre-attentive stage after the stimulus onset, and it appears between 80 and 100 milliseconds. And often it's followed by a positive peak around 200 milliseconds, and this appears always with visual stimulation. So when we look at, compare this N1 and P2 complex, it exhibits a larger value for the higher intensity condition. Also, those components were larger for the three phases compared to the neutral condition. And I'm going to break down the result for you here. Since N100 is a negative value, this is the one at the bottom of the screen, and the one on the top is the value for P200. First, there was no difference for the tactile, for the visual only condition and the neutral condition. When a happy phase appeared first on the screen, the signal was significantly higher when associated with the lower intensity, the one in orange. 200 milliseconds later, the trend changed and became significantly higher for the medium intensity. For sad phases, it was significantly lower when associated with low intensity, around 100 milliseconds. Later, for P200, it became significantly higher for low flow. And finally, for angry phases, it was significantly higher when associated with the medium intensity, around 100 milliseconds. 200 milliseconds later, no difference between the flow, it flattened down. So if we take this to a virtual environment, when you interact with virtual avatars, for a happy avatar, the tactile sensation could start at low intensity and change to a medium intensity. For sad, it can start at a medium intensity and change to high intensity. While for anger, it starts at medium and gets reduced to low. Interestingly, when we look at the physiology of anger, it makes sense. Anger starts with strong physiological responses such as muscle tension, high blood flow, and then it went down. It has a wind down phase. So this will require additional experiment because we need to explore other intensities, speed and duration, and match them with the physiological response of emotion related to emotion. In terms of rating, since we asked the participant to rate the pleasantness of the stimulus, the participant found the higher level of intensity highly unpleasant, while the low level of intensity was rated most pleasant. We suspect that those rating, especially the non-pleasant rating, the temperature of the air jet was actually quite cold. And in the future, we didn't have control over it, but in the future, this aspect need to be controlled since temperature is an important contributing factor to emotion. I use perceptual illusion a lot in my research because they help me understand how humans perceive and interact with their environment, whether it's natural or virtual. And when you understand, there is no illusion anymore if you can understand the perceptual mechanism that causing the deception. A robust illusion in touch, known as the cutaneous rapid illusion, or CRE, also known as saltation, can be used with virtual object. The one I use in the study consists of 3 successive taps delivered at 3 different locations equally spaced on the skin. Participants report not 3 locations, but a distributed sequence of taps across the skin. So what you see in gray here is a constructed simulation. There is no real contact with the skin. Participants described the sensation as it was a tiny habit hopping on the skin, and hence the name, the cutaneous rapid illusion. The illusion works better in low acuity areas, such as the forearm, and the name given is just a metaphor because really no one experienced a tiny rabbit hopping on their arm. But I wanted to play with this metaphor, and also because in real life, people might have experienced tiny insect animals hopping on their limbs. Saltation is actually a form of locomotion that means hopping, and rabbit is a saltatorial animal. Those animals get around by jumping and hopping, and you can see few of them jumping and hopping on this slide. The first study started at the end of 2016 with this paradigm, so I'm going to use this paradigm for the next 3 studies. So it was during the end of 2016 during a research stay in Finland at the University of Tampere with my collaborator, Professor Rupi Raisamo. And the purpose was really to determine the interaction between visual emotional images and the cutaneous rabbit illusion. And we also wanted to play with this metaphor of a hopping rabbit. From previous research, we know that the tactile stimulation, there is 2 factors that affect the CRE. The burst duration, which is the duration of the vibration itself, and the interburst interval, which is a time between 2 vibrations. The first step was to compare which features of the CRE works better with our paradigm. So we ran 2 experiments for the second study. So in experiment 1, we varied the burst duration and kept the interburst interval fixed. And experiment 2, we did the opposite. We varied the interburst interval and we kept the burst duration fixed. From previous study, we know that CRE works better if the total duration is between 250 milliseconds and 600 milliseconds. So we try to stay in this range. And then in both experiments, we kept the fixed factor at 24 milliseconds, and we vary the varied factor at 12, 24, 48 milliseconds, resulting in 3 tactile conditions. We combined the tactile stimulation with silhouette of saltatorial animal to assess the emotional dimension of the tactile stimulation. And you can see here, there is a mix of unpleasant and pleasant animals to affect the emotional dimensions. And this is where the minimalist approach I talked about earlier comes to play. We kept the visual stimulus very simple, just black silhouette, to avoid any effect of color, shape, texture, or depth. So we ran the first experiment in Tampere when I was there with 14 participants. We had 240 trials. We had 1 visual only condition and 3 tactile condition. In the second experiment, we had 25 participants, same 240 trials, except in this case, we only exposed them to the tactile condition combined with the images. And in both experiments, we asked the participant to rate the strength animal-tactile association and report any phobias. As you can see here for my image at the bottom, participant is wearing a sleeve, and inside the sleeve, there is 3 actuators at 3 different locations. And the image was displayed on the screen in front of them, and it's moving from left to right at the same time than the tactile simulation. I hope you can hear my sound. Here an example, you will hear a buzz instead of a tactile vibration. I'm not sure if I activate the sound when I share my screen, but hopefully you can hear it. If you don't, please let me know. So what you're going to see is an animal hopping from left to right, and you will hear a buzz at the same time. It's going to be very fast because I try to keep it realistic to the real timing. It's less than 1 second. So there will be 9 flashes in the 3 different locations. So let's see, hopefully you can hear it. Are you able to hear that? I'm not sure.
Yes.
Oh, fantastic. So that's the, and then the main task was to rate the tactile simulation using a self-assessment mannequin test. This test is a very powerful, has been used with multiple times, created in 1994 based on the PAD emotional model of Mihrabi, and PAD stand for pleasure, arousal, and dominance. So for example, the participant can select 1 if the tactile stimulation make them feel happy on the valence dimension, excited on the arousal dimension, or controlled on the dominance dimension. They can select 5 if they feel neutral about the stimulation. They can select 9 if they feel unhappy, calm, or in control of the situation. And each emotional dimension rating is independent from each other. So they are not obliged to pick the same number for each dimension. So we have multiple scenarios, but I can talk about one single hypothesis that we want to avoid. Ideally, you want tactile intensity that affect positively, or even if it's negative emotion, doesn't bring the level of stress to a high level. So you want you want strong emotion, but you want the right kind of emotion. So for instance, you don't want a participant to be in a situation where they feel unhappy, excited, and controlled. Which can be translated, in other words, being stuck in the virtual world. You would like to create the right kind of emotion because you want to create comfort and not the opposite. Don't worry, there is a lot on my graph, but I'm going to break it down for you. So first, for the longest duration, it was significantly higher when associated with larger animal. For the intermediate duration, higher score were associated with smaller animal. And this is the 2 most interesting results for us. The less pleasurable the animal was on the scale, the less variation was noticeable between the 3 burst duration, while the variation was significantly perceptible for pleasant and neutral animal. For arousal and dominance, when animals were rated higher in the visual-only condition, they were rated lower with any of the tactile condition. And those that obtain lower scores in the visual-only condition were rated higher when the tactile stimulation was present. For the second experiment, we did not find any difference between the 3 tactile conditions. You can see that most of the graph overlap here. We did find a significant effect of the animal factor, but this is not surprising since they carry emotional connotations. When we asked the participant, which animal would you associate strongly with the tactile sensation? The smallest animal were the one who were associated strongly to the tactile sensation, while largest animal reduced the effect of the hopping sensation. So this is our winning formula for our first investigation using the cutaneous rabbit illusion. Varying the burst duration is more effective for emotional variation than varying the interburst duration. So for the next experiment, we decided to not use this configuration anymore, and we use this configuration for the following experiment. To summarize this study, we find some interesting results, but it will require additional validation, which we try to do with the following experiment. Valence was dominated by vision for unpleasant stimuli. If you look at happy and neutral stimulus, there was difference between the tactile sensation. So we could speculate that when exposed to a fearful or unpleasant visual stimulus, the participant cannot judge the tactile stimulation anymore because it will feel aversive no matter what. And this could be very similar to human touch. When the person engaging in touch is not welcome, no matter how light or strong is the touch, the person experiencing the touch will be aversive to the situation. For both arousal and dominance, we think they can be modulated by tactile sensation. For example, a stimulus judged excited in the visual condition only was rated calming when associated with the tactile stimulation, while the one judged calming were rated more exciting when associated with the tactile stimulation. If we want to translate this to a VR or a setting, it can be beneficial if the visual stimulus has a low level of excitement. A tactile stimulation could enhance that, and the opposite can be true. If a visual stimulus has a high arousal or dominance level, a tactile stimulation could help reduce those levels. And this has been consistent with some participant comments. They mentioned that the weakest tactile stimulation had a calming effect for the least pleasant animal. So we decided to continue with this paradigm and explore what are the other factors that can affect this dynamic. Since the cutaneous rabbit illusion has been described as a distributed sensation across the skin, we wonder if the number of visual stimulation will affect the multimodal experience. So in this third study, we decided to vary the numerosity of the visual stimuli and how it affects the emotional dimension. So the tactile sensation remained the same, 9 successive taps, but we had 3 images in 3 different locations, 5 in 5 locations, and 9 images through 9 locations. There is an additional difference between these conditions. For the third, the 3 location and 9 location, there is always an image associated with the tactile sensation. The 5 location creates some kind of mismatch between visual and tactile. So there is 4 tactile vibration that will have no image associated to it. So we used the same apparatus as before. We had 12 participants this time, and they completed 384 trials. We add a tactile condition, tactile only condition, and then we had the combined 3 numerosity condition, 3 tactile, and the 8 animal. And the task was the same: rate the emotional dimension of the tactile sensation. For a better assessment of the emotional rating, we decided this time to do a different type of analysis, which is the relative percent change. And this really showed the relationship between the tactile stimulation alone compared to the multimodal condition. For example, if the rating of a tactile stimulation alone is 3 and is 6 when combined with an image, it means that the relative percent change of this condition went up by 100%. And this is the first interesting result, is the one you see on this graph. So by adding the visual image, unpleasant animal ratings such as spider and flea increased by 100% and almost 80% respectively, confirming the idea that violence is heavily influenced by visual stimuli. The second interesting finding is the following: even if some of the tactile sensations were constructed on the skin, the numerosity need to make sense. And this finding goes hand in hand with multisensory integration principle. A visual and a tactile stimuli need to be synchronous and congruent in order to make sense for the perceiver. The 5 location condition broke down completely the illusion and create conflict between vision and touch. Since we did not find any significant effect for this condition, I'm not discussing it in the follow-up analysis. So the first another finding for violence is numerosity 9 reduced the valence value, which means that 3 images enhances valence value. The longest duration was significantly higher for rabbit, which was the most pleasant animal. The shortest duration was significantly higher for kangaroo rat, and the shortest duration was significantly lower for flea, which is the most unpleasant animal. For arousal, the longest duration was significantly lower for rabbit. The shortest duration was significantly higher for flea, and the numerosity 9 increased the arousal value for some animals, and in this case, rabbit, grasshopper, and flea. The same trend has been observed for dominus. The longest duration was significantly lower for rabbit, and the shortest duration was significantly higher for flea, and the numerosity 9 increased the dominance value for some animals. So to summarize this, increasing the visual stimuli reduced the distinction between the tactile sensation if there is a mismatch between the visual images and the tactile stimulation. And that if you are adding haptics in a virtual world, the haptic sensation need to be congruent and be placed simultaneously, that whatever visual stimulus is on the screen. the other finding was it can also modulate positively the emotional dimension by making those the scores happier, calmer, or more in control, which was the case with numerosity 9. The choice of the unpleasant visual stimulus matter. Spider, flea, and grasshopper are all has been ranked as unpleasant animal, but they did not rate similarly on the scale. Spider was too unpleasant to pay attention to the tactile simulation. So this is why we didn't find any effect of the spider. Flea, which was the second unpleasant animal, was affected by the numerosity 9 and the shortest duration, which these two conditions make this unpleasant animal, when exposed with those conditions, more pleasant, calmer, and more in control. And it was the same for grasshopper, the third least pleasant animal. This difference is actually, we think it's related to phobia. We didn't have a lot of people reporting phobia, but for this experiment, we did actually have 8 of 12, which is more than 50% of our participants reported arachnophobia, which is the fear of a spider. So, and when we asked them to rate the strength of the tactile and visual association, this was significant between participants who reported spider phobia and who did not. So we know that for treatment for phobia, multiple clinics use VR for phobia treatment and to help people get off their spider phobia. To my knowledge, no tactile sensation has been used so far with the virtual environment. So we can imagine that this multimodal CRE or this multimodal cutaneous rabbit illusion can be used as an intermediate phase before touching a real spider. If you're familiar with the cognitive behavioral therapy, usually the last phase of the therapy is to ask the patient to hold the spider on their hand, a real spider, or they let it crawl on their arm. And there is a phase just before that where they ask them to babysit a spider in an aquarium for a short period of time. So if they succeed keeping the spider in their room for a week or so, they can move to the next phase. And I think there is a high rate of giving up at the aquarium level. Some people don't never go with putting a spider on their hand. So we can imagine to include the CRE just before the last phase, so they can be in a VR setting and feeding a spider on their arm. And hopefully we have to try this. So that's just a speculation, but in my work, it also can be used, this paradigm can be used in games to add fear to the interaction when you're seeing spiders in the virtual environment. The reason we didn't find effect of the other animals, we did find a tiny effect for kangaroo, but nothing for Burrell, which is a Himalayan blue sheep. I feel like these two animals felt too big, their real size in life. It's too big to be hopping on their arms, so they kind of break down with the illusion. The frog, we were very surprised, but we realized, yeah, we are actually having a static pose, and it will have reduced the sensation of an animal hopping across the arm. But this gives us actually an idea for our next experiment to actually think about dynamic images and focusing on the starting action and the end action. So either the aerial phase of the locomotion or the touchdown. So we also projected the images directly on the arm this time to strengthen the association between the visual images and the tactile sensation. So this is our new system. So we use the same sleeve. So this is here, you can see the actuators. And we had like a white cloth here on the arm. And then, as you can see by my animation, you have 3 images here, 3, because it's a very short duration, you won't see them flashing when it's recorded. So this is a difference from our previous study where images were, in the past, the images were displayed on a screen in front of the participant. In this case, the image location was congruent with the location of the tactile simulation. And they were projected directly on the arm. So for the tactile stimuli, we kept everything the same. And for simultaneously to the tactile sensation, we had 6 silhouettes of 6 animals, a mix of pleasant and unpleasant, with 2 locomotion conditions, taking off and landing off. So the taking off start with jumping, landing, and then jumping and landing, start with landing, jumping, and then landing. 23 participants from Bentley participated in this experiment. They were exposed to 140 trials, and they were asked to rate also the strength of animal tactile association and to report any phobia. And again, this task was the same, using the self-assessment mannequin test to rate the 3 emotional dimensions: valence, arousal, and dominance. A bit surprised by the result, because usually valence, we do find some result for the tactile condition, but in this case, there was none. There was only the factor, significance of the factor animal. And that's shown in this graph. Rabbit and kangaroo score lower, significantly lower on the scale than spider and flea. For arousal, that was interesting because we did find an interaction effect between tactile and locomotion and the factor tactile and animals. So to break down this interaction, this is our interaction graph. And so all scores for taking off condition, what you see in blue, were higher when associated with the intermediate duration. The opposite tendency was observed for the shortest duration and the longest duration. Score for the landing condition that you see in orange were higher for the taken off condition. We didn't find any effect of the dominance, and since the dominance did not show any significant tendency, we decided to examine the relationship between valence and arousal using the circumplex affective model. So, for example, if you looked at this segment, all the 24, which is the intermediate duration, and landing pairs, the combination between landing condition and intermediate duration, are in the happy segment, while, and this is for only pleasant animal, and for pleasant animal that are in the takeoff condition and the intermediate duration, were in the relaxed segment. For unpleasant animal, the intermediate duration, when combined with the takeoff condition, they were in the depressed segment. And when the intermediate duration was combined with landing condition, they were in the angry segment. I would not have time to go over all this segment, but there is more details in the paper, and this table summarizes all the different emotion pairs. So to summarize the study, the visual representation of the animal was strong enough to offset any effect of the locomotion or tactile sensation, indicating and validating again that there is a dominance of vision for the pleasurable dimension. The dynamic nature of the images enhance the visual dominance, and this is why we didn't find any significant result of the tactile sensation when, as opposed to the 2 previous studies. So on one hand, this is good news for designers, as there is no need to invest in expensive technology during testing. On the other hand, it will represent challenges if the purpose is to distinguish small nuances between the different tactile sensations during a visual interaction that is constantly changing. And this is the case in VR. Everything is changing. It will be better in this case to assess or to the valence dimension of the tactile modality alone before adding it to the VR interaction. For the arousal dominance, an interaction effect between the locomotion and the duration was found. A plausible explanation is this combined factor provide a distortion of time that can contract or dilate the perception of the tactile stimulation depending on which pair has been presented. And this explains the change in the rating. So based on what we've seen, if, for instance, the designer wants to convey happy and angry emotion, it's better to consider to use the tactile feedback during the pause of the movement. For instance, let's take the example of walking. It's going to be during the contact phase, while relaxed and depressed could be better conveyed when the emphasis is made on the action itself or the propulsive phase. It's also a phase of walking, for instance. So rather, I think, than focusing on balance and arousal as one single dimension, it will be beneficial to take a holistic approach by considering them simultaneously. So this summarizes what we think it could work based on all the study I mentioned today. So when a visual stimuli is highly unpleasant, a tactile stimulation is less likely to modulate emotion. It is still not clear for moderately unpleasant animal, but there is room for emotional modulation. There is also more room for pleasant stimuli. A tactile stimulation can modulate emotion for pleasant stimulation, pleasant visual stimuli. For arousal and dominance, when they score lower on the scale, a tactile stimulation could modulate emotion, and the opposite is true when they score higher on the scale. Imagine a very calm game where you feel in control of the situation. The tactile stimulation can bring some level of excitement or fear. This is what we are working currently with my current collaborators on the project. We are investigating an additional manipulation of the haptic feedback, and this is exactly what we think hopefully could happen, which allow us to alter emotion by changing the intensity of the burst themselves. For now, they play all at the same intensity. So based on our previous finding, a decrease in intensity will have a relaxing or a calming effect. So if the intensity starts at 100%, in the second burst is going to be reduced by 25%, and the last burst, it will be reduced by half. So it's almost like a funnel, we call it actually a funneling effect. While increasing the intensity will produce an aroused reaction. So we are testing this right now. The next step for this work is to progress from a projected setting to a VR setting. But before doing so, we still need to investigate additional aspects such as stimulus type and the location on the screen of the stimulus. So, but I want to show you a few scenarios that I'm thinking about. So take, for example, a scenario 7, a VR situation where the user feels unhappy, excited, and control. This scenario could put the user in a defensive and even dangerous emotional state if the haptic feedback is used. So for instance, seeing your avatar being eaten by a zombie is unpleasant enough. Adding haptic feedback will bring the interaction to another level that could not be comfortable for the player. Now take scenario 8, seeing someone else being beaten by a zombie. This situation will affect negatively, both violence and arousal without affecting negatively the dominance dimension. The person is still in control, which is related to the social context. So in this specific case, a haptic feedback will enhance the game without putting the user into an intense distress. I don't know if probably I finished early, but thank you for your time and attention, and I welcome any questions.
Thank you. Let's see.
Should I stop sharing my screen? I think maybe then.
Yeah, that would be great. Okay. So I did notice that Philippe had some questions in the chat. So I didn't know if Philippe wanted to.
Yes. Should I start with the chat first?
Well, I was thinking that since Philippe posted early, that there's also the Miro board and also whoever is raising their hands. So, but yeah. So do you want to start with Philippe? Is Philippe?
I show some hypothesis. Did you do a stimulus check to verify if the affect related stimuli was indeed associated with? Yes, we did have when you made a stimulus check. So we had tactile only condition, visual only condition, and that was our control conditions. So we asked them to rate the simulation alone, and then we asked them to rate it into the multimodal condition. And then if you have to speculate about the interaction between different haptic modality example, yeah, that's a good question. Temperature is one of the challenges when it comes to haptic interaction, because it's very difficult to control in terms of timing. You can change temperature from cold to warm in maybe 3 seconds, but if you want a very fast temperature change, is going to be hard. But there has been research showing, like, for instance, that has been done with how you perceive the person. So they give people, they hold a warm cup of coffee versus a very cold cup of coffee, and then they ask them to shake a hand with the other person, and the person who was holding the warm cup of coffee was perceived as being more warmer, and the one that had a cold cup of coffee, they were perceived as being a cold. So clearly temperature affect emotion. But yeah, we did. I tested in a VR sitting in the past, but I test how it could affect, and that's a different paper, 2016. So what we did with this one, we combine temperature in a VR sitting with colors, and when the visual stimulus was actually affecting the temperature rating. So when you are seeing a red cup and you are feeling it cold, people think it was less cold, so it was more on the warm side. And if they are holding a real warm coffee and they were seeing it blue on the screen, they thought it was less warm. So there was an interesting interaction there. I hope those answer your questions. Should I go to Miro?
Well, also Demetrius has his hand up.
Yeah, Demetrius.
Hi, thank you for the presentation first. I wonder if you could review the types of tactile stimuli you used and then speculate about other types. I'm thinking, for example, if you've been in some of these massage chairs,
yeah,
that grip a large part of your leg or arm, or squeeze them, or vibrate on parts of your body, or sharp prick somewhere. And it seems for VR, those might be very effective in certain situations.
Yes, I do agree. Thank you for the question, Demetrios. I show you two types of vibration I use. I use the air jet. And the reason I use the air jet in the first experiment, because the timing, it really can feel like a breeze on the arm. So that was the reason why we used this one, and controlling the timing of the stimulation was very good. The intensity, the flow. The only issue we had is because we use an air compressor, so we were not able to warm the air. So it was a bit challenging to get. The technology I use here, it actually voice coils. So it's voice coils that are amplified. We use an amplifier to amplify the sound at 250 hertz. So they feel vibration. They don't hear it, but it's a vibration on the skin with an amplitude of 250 hertz. There is a different type of technology. There is kinesthetic feedback, like devices that provide force, devices that squeeze the arm. But and this is the reason why at the end I say we need to test different type of stimulation to make sure that it can be same or different from one stimulation to another. So the technology matters.
Thank you.
Okay, on the Miro board, there's something that I think kind of follows from that question. If the bunny hops in the opposite direction on the screen from the air jet sequence, does that break the illusion?
Yes, it will. Yeah, it will. This we show even like in the five the numerosity where we had only 5 rabbits. And we tried to synchronize this, and still, even if it was less than 100 seconds, like 600 milliseconds, it still break the illusion. So yeah, it will.
Another question was if there are any good pointers to equipment to experiment with haptics in a non-university setting.
Yes, there is. So the first, you can do actually Arduino offer right now very cool stuff with haptics. I use this in my multisensory experience design course. So you can, it's only vibration, but you can also use pressure type of tactile feedback. Now, especially with the growth seed, which is, I will write it for you here in the chat. Growth seed with 3 E. So this one is a module that you plug directly, so you don't need to know a lot of programming to do you plug it to an Arduino board, and it will create simple vibration. There is also a new kit that has been developed by my colleague Marcy O'Malley. I do have one here in my house. And I'll try to, but it's a new kit that being used specifically for Unity. So you can have up to 16 vibration. It's still vibration, it's not, but it's a very, very interesting device. I'm having a lot of hope for this one. And they also created scripts with Unity that you can test. So it's specifically dedicated for a VR environment and other type of haptic interaction. So she's at Rice University. So this is for like if you want to learn about haptics. The one we used to use a lot is the Omni Phantom, but this is not a cheap one. I mean, the cheapest one is like $2,000. So, and they do have up to $30,000. But yeah, so even like when we did the EEG one, we were the timing with the airjet was still slow comparing to the visual stimulus. The challenge we have with those devices is the timing of the vibration. We can display a visual stimulus for 200, 300 milliseconds, the vibration as well. But if you want more precision, the timing of the duration, there is a delay between the visual and the tactile.
Okay, another question was, has the pandemic and our physical separation accelerated any research into the role haptics can play in visual interactions?
Yeah, that's a challenge. Our conference is going to be online. It's in Montreal. Well, it was supposed to be in Montreal in July. And one big thing we have is demonstration. We do have demo is one of the big things. I was able to run during first in January an experiment. Bentley has been amazing in providing me with all the security guidelines and safety. So we were able to run 20 participants, which was very cool. But yeah, it has been challenging, that's for sure. But you know, the argument is when we present sometimes our work, we use sound to convey the sensation, and this is what I did with the rabbit. So sound is not different from touch in a sense, because sound is also waves, and it's also about vibration, and touch is also about vibration. So it's going to be that's the less challenging is we can use sound to convey what we want to. But it's clearly, if you want subtle tactile sensation, you want to try stuff, and it's going to be challenging to use just videos or to convey this.
So is there more interest in this type of research because of the pandemic?
Yes, clearly. There is also a big area of haptics called mid-air haptics. And mid-air haptics is actually, I do have a device in my lab. It's UltraLeap. I just put it in the chat. So UltraLeap use ultrasound. So you're not touching. It's almost like the air jet I show you is also mid-air haptics. So there is no touching. So there is those directions where there is no touch, but you still feel tactile sensation. So UltraLeap was previously called Ultra Haptics, but they merged with the Leap motion. I think it's Motion Leap. I think there is Motion Leap and Leap Motion. I don't remember which one, but they are based in UK, and there is a lot of hope using this technology. The challenge for this technology is very low resolution comparing to what we want. So if you are looking into a rough haptic feedback, it's good, but if you want precision, this is not the right technology for precise and subtle tactile sensations.
Philippe has a question.
Hi, Mounia. First of all, amazing talk. Thank you so much. Super informative. I have a question regarding when you use the air jet. Again, the idea of exploring emotions and affect in this case is also very related to, I don't know if you heard about interoceptive pathways. So they're afferent pathways that are both nociceptive but also affective. So that's pretty interesting that you used air jet. I was wondering if you can speculate if you use, for example, VCMs or other types of actuator, if you think you would have obtained the same type of result.
Yeah, very, very good question. I think the technology matter. And I do know, like, for instance, in the past, I use electrostatic versus vibration, and it's not going to be the same. So, and this is why what the result or the hypothesis, it's just based on this specific technology. But we need to use the same paradigm with different technology and compare them. So I cannot speculate in one way or the other, but what we wanted to do actually with this, when we started with the airjet, we wanted actually to compare, we wanted to put a curtain and compare a real human touching versus the robot touching, like the airjet. And it really felt like a caress on the skin, really. So it will have been hard to tell behind the curtain, but it was very challenging to find a human that will mimic the speed, the rate of the. So it will have been challenging because when you do EEG, you need to synchronize the movement. It's just a matter of timing. You have to. So it will have been one solution will have been to connect the finger of the human to some kind of motion sensor and send this to EEG, but it was just some technological challenges, so we were not able to do it. So that was the initial idea, and this is how are we going to assess emotion? And since we are using this, the purpose was to do this for VR in the future. Emotional faces has been used in psychology and vision research for years and years and years. So this is why we decided to go with that. But I do agree that we need to test different type of haptic technology because it might be, the conclusion may be completely different.
Thank you so much.
You're welcome.
Great. Does anyone else have a question? Anyone really wants? No. All right, I think, was that somebody? I didn't see anyone raising their hand, but so I think I guess we're all set. It was an excellent talk. Thank you so much, Mounia, and I learned about new animals also. I didn't know what a barrel was before. So.
That's actually, I think that's the reason also we didn't obtain any rating, because it wasn't a familiar silhouette. So this is why we remove it in our last study. And we kangaroo rat also, it's not a common animal. So we decided, okay, but there isn't too many hopping animals. There isn't too many saltatorial animals in the world. So there was the hopping spider, the grasshopper. So we wanted to make sure that we kind of get a cover range, but some are really cultural related. So.
No, that was excellent. So thank you so much.
My pleasure. Thank you for having me.
And we will be posting the video, and If anyone wants to follow up with you, do you mind if people get in touch with you?
Yes, I put my LinkedIn in the LinkedIn. So yeah, please, anytime.
Oh, thank you.
My
Bye-bye.
pleasure. Thank you.